Load and performance testing of highly available and distributed systems is essential to ensure that these systems can handle real-world workloads, scale effectively, and maintain uptime. These systems are typically designed to handle large volumes of traffic, ensure fault tolerance, and provide consistent performance across geographic regions. Here's an overview of how to approach load and performance testing for such systems. Key concepts. 1. Load testing. Goal: understand system behavior under expected and peak loads. Tests: gradually increase the number of users/requests to simulate real-world usage. Metrics to monitor: response time, throughput, requests per second, error rate, CPU/memory usage. 2. Stress testing. Goal: identify the system's breaking point or maximum capacity. Tests: push the system beyond peak load until failure occurs. Use: understand how gracefully the system degrades and recovers. 3. Soak testing, endurance testing. Goal: ensure the system can handle a typical load for an extended period. Use: detect memory leaks, database connection issues, and performance degradation over time. 4. Spike testing. Goal: test how the system handles sudden bursts in traffic. Use: measure recovery time and system elasticity. Components of distributed systems to test. APIs, microservices. Test each service individually and as part of the whole system. Load balancers. Verify request distribution and failover behavior. Databases, caches. Test for query performance under load and replication lag. Message queues, event streams. Measure processing latency, back pressure handling. Geo-distributed nodes. Measure latency and data consistency across regions. Tools. Category tools. Load testing: JMeter, Gatling, K6, Locust. Distributed load testing: Artillery, Taurus, AWS. Distributed load testing. Cloud native: Azure. Load testing, Google Cloud. Performance testing. Monitoring and observability: Prometheus plus Grafana, ELK Stack, Datadog, New Relic. Best practices. 1. Test in a production-like environment. Use the same hardware, network, and configuration. Include redundancy, multiple replicas, availability zones, etc. Simulate realistic workloads. Use real usage patterns, login, read/write mix, caching behavior. Include randomness, delays, user think time. 3. Use distributed load generation. Deploy load generators across regions. Ensure the test isn't bottlenecked by the load generator itself. 4. Incorporate chaos testing. Kill services/nodes during the test to observe system resilience. Tools: Chaos Monkey, Litmus Chaos. 5. Monitor everything. Infrastructure: CPU, memory, disk, network. Application: response time, request rate, error rate. Business KPIs, cart additions, checkout success, etc. 6. Automate testing in C/CD. Run performance regression tests on every release. Compare with baselines and raise alerts if degraded. Sample metrics dashboard. Metric: normal under load. Average response time less than 200 milliseconds, less than 500 milliseconds. Error rate less than 0.1%, less than 1%. CPU usage less than 70%, less than 90%. Memory usage less than 75%, less than 85%. Latency, P95/P99, less than 300 milliseconds, less than 800 milliseconds. Common pitfalls: not testing downstream systems, DB, cache, third-party APIs, ignoring regional latency differences, overlooking rate limiting, auto-scaling behavior, lack of cleanup, stale data can skew results, only testing success paths, for example, not simulating failures. Summary: load and performance testing of highly available and distributed systems is more than simulating traffic. It's about validating architecture, resilience, scalability, and observability. It requires a combination of realistic scenarios, robust monitoring, and automated regression tests to ensure reliability under stress. Comparison of JMeter, Gatling, K6, and Locust. JMeter. Language: Java, with GUI and CLI modes. Protocol supported. HTTP/S, FTP, JDBC, SOAP, JMS, TCP, WebSocket, SMTP, IMAP, POP3, LeDAP, via plugins audio/video testing. Can test HTTP-based streaming, for example, HLS segments, but not media quality or real-time streams. Custom code support. Yes, extensible using Java, custom plugins, samplers, BeanShell, JSR223, Groovy/JavaScript scripting, custom libraries and assertions. Gatling, language, Scala, DSL, also supports Java. Protocol supported. HTTP/S, WebSocket, JMS, Enterprise, MQTT, limited audio/video testing. No native support for streaming or AV quality testing. Custom code support. Yes, highly extensible via Scala/Java. Create complex user behaviors. Use any Scala/Java library. Write plugins or custom protocols. K6, language, JavaScript, ES6 protocol supported. HTTP/S, WebSocket, gRPC, MQTT, via XK6 extensions audio/video testing. Can simulate streaming endpoints, for example, HLS, but no AV playback or quality testing. Custom code support. Yes, highly extensible. Write scenarios in JS. Extend using XK6, Go-based plugins, integrate with C/CD easily. Locust, language, Python. Protocol supported. HTTP, HTTPS, WebSocket, via extensions, gRPC, via custom Python clients audio/video testing. Not suitable for real-time AV testing. Custom code support. Yes, fully scriptable in Python. Define user behavior with full Python power. Use third-party libraries, for example, gRPC, WebSocket client easily extend for non-HTTP protocols. Here's a short overview of Artillery, Taurus, and AWS distributed load testing, tools used for performance testing, especially in distributed or cloud-native environments. Artillery. Language, JavaScript, YAML. Best for lightweight, scriptable load testing for HTTP, WebSocket, and serverless. Key features. Simple YAML or JS-based test scripts. Supports HTTP, WebSocket, Socket.io, and custom plugins. Good for testing APIs and serverless. AWS Lambda custom code support. Yes, JavaScript hooks/plugins AV testing, not supported. Taurus. Language, YAML, config wrapper best for unifying and automating tests across tools like JMeter, Gatling, Locust, and more. Key features. Acts as a wrapper for other tools, JMeter, Gatling, Locust, etc. YAML-based configuration, easy scripting integrates with C/CD, for example, Jenkins custom code support, inherited from wrapped tools. AV testing, indirect only, via JMeter/etc. AWS distributed load testing. Platform. Managed AWS service, open source reference architecture best for scalable, cloud-native load testing on AWS infrastructure. Key features. Based on JMeter or custom test scripts. Auto-scales test workers using AWS Lambda and ECS, no server maintenance needed. Custom code support. JMeter scripts or custom containers AV testing, limited, depends on script, usually HTTP only.